Right, so now that we managed to upload a file to the target computer using the low security level, let's see if we can do it if we increase the security of the target website. So I'm going to exit out of this, and I'm going to go to my vulnerable web. Let's go to the security settings, and at this, before it was set to low, so I set it there to medium, then click on submit. And now the security level is medium. So let's go back to our file upload and try to upload our shell right here, the same shell that we uploaded before. And I'm going to click on upload the exact same way. And as you can see, it's saying your image was not uploaded, and it's complaining about the headers. Let's see if we can upload an image. So let's just make sure that the program didn't break and we can still upload images. So I'm just going to upload the same image, again, the car image, and I'm going to upload. And as you can see, we can upload images, but we cannot upload PHP files. So obviously now the target is more secure. And now we're approaching this from a black box point of view, so we don't have the source code to see what's happening. So there's a number of ways that you can filter the files uploaded. One method is to check if the file is an image, to check the file type. If it's an image, then upload it. Otherwise, don't do that. If that's the way that they're doing it, then we can bypass that. So let's see how we can do that. First, the file is being uploaded using a post method. So to modify the post parameters, we're going to use burp suite. I'm going to click on burp suite here. So we're going to go on the proxy side in here, proxy tab. And before we can use this, we just need to set up our browser to use burp suite. I'm going to click OK. And now everything I do on this browser right here will be sent through burp proxy. So what we're going to do is we're going to modify our file right here, the shell.php. And because we can upload JPG images, I'm going to rename this file and I'm going to call it shell.jpg. Now, obviously, if I upload this file this way, it's not going to work because it has a JPG and not a PHP extension. So the target computer or the target server, when I try to run it, it'll just try to run it as an image, and I won't be able to execute the code that I want to. So we're going to upload it as an image first, and then we're going to intercept it in burp suite and convert its extension to PHP to bypass the filter. Let me do it and it'll become more clear. So I'm going to click on shell.jpg, upload it. Now this upload is being intercepted in here. And let's see what's happening. So you can see that the file is being uploaded. The content type is trying to be image.jpg and the image is shell.jpg. Now what we're going to do is we're going to modify that and set this to PHP. And we're going to leave the content type to image. This will allow us to bypass the filter, and it will store our file as shell.php. Now, just to make sure that this is not going to overwrite the old shell, and you'll think that nothing got uploaded, I'm going to call it shell2.php. So that's it. I'm going to forward this packet. And as you can see now, we get a message saying, now the file has been uploaded and it's called shell2.php. Now, if we go back to our terminal and use the same URL we were using before, because it's the same shell, same password, I'm just going to call it shell2.php and try to communicate with it. I'm going to hit enter. And as you can see, now I managed to connect to the target computer or to the target server, and I managed to upload my shell by intercepting the packet and changing the file name from JPG to PHP. Okay, now that we can bypass the checking for the file type, let's see if we can bypass it when we increase the security level to high. So again, I'm going to exit this and I'm going to go to the website settings here in DVWA. And as you can see now, this is still running. So it's intercepting every packet. I'm gonna click this to turn it off so I can browse the internet normally. And I'm gonna go on hi. I'm gonna submit that. And now that's all good. So the security level now is high. I'm gonna go to my file upload. I'm gonna try to upload a normal image just to make sure that nothing broke like we did before. So I'm just gonna upload the car image. And as you can see, we can upload JPG extensions. So I'm gonna turn on my interceptor again so I can see what's happening. And I'm gonna try to upload my shell right here, .jpg, like I did in the previous video. I'm gonna click on upload. And I'll just try the method we tried before and see if that works. So in the previous method, the target computer or the target server was checking if the file type is an image. So when we called our file JPG, it was only checking if the content type is an image. So when we come here and change this to PHP and forward this packet, the upload used to go through. Now you can see that it's telling us that the image was not uploaded. So it's probably checking that the extension is JPG as well. So it's checking the file type and the extension. So we can bypass the file type like we did before, but now it's checking for the extension. So we can't really bypass it that way. So what we're gonna do is we're gonna do a trick that I'll show you now. So I'm just gonna upload the file again. Same file, shell.jpg, and I'm gonna click on upload. What it's doing right now, it's checking that the content type is an image.jpg, which is perfect. That's cool. We can do that. We bypassed that last time. What it's also checking this time, it's probably, we don't know, but we're assuming that it's also checking that the file type is .jpg at the end. So when we're changing that to .php, everything is breaking because it's expecting a .jpg file or .png. So it's expecting an image extension. So what we're gonna do is we're gonna do .php .jpg. So we're gonna call the file shell.php.jpg. This way, it's gonna check if the last thing is a .jpg, and it's gonna think that it is a .jpg, so it's gonna upload it to us. Then we're gonna browse it like a PHP file, and it should work for us. So I'm gonna call this shell2, or actually we'll call it shell3. So the only thing we modified now is we modified the file name in here to shell3.php.jpg. I'm going to forward this packet. And as you can see now, the file has been uploaded successfully. Now I'm going to go back to my Weebly here. And the last file we interacted with was called shell2.php. This time our file is called shell3.php.jpg. We're gonna hit enter, and as you can see, we managed to connect to upload a PHP file and execute it on a target computer using Burp proxy to keep the file type as an image, and then we changed the file extension to .php.jpg, which bypassed the file type check as well. So if I do ID now, I can get my ID. If I do pwd, I'll get my working directory, and in the future we'll see how we can use Weebly, but for now you can see that we managed to gain access to our target website. In this lecture, we're going to have a look on file upload vulnerabilities. These are the simplest type of vulnerabilities because they allow us to upload any type of file. So, for example, if the target computer can understand PHP, then we can upload any PHP file or a PHP shell and get full control over the target computer. Now, if the target computer or the target server understands Python or any other language, then you can just upload Python code, Python shell, or Ruby shell. You can create these shells using Vil Evasion or Metasploit, or you can use your own PHP or Python shell. What we're going to do today, we're going to have a look on a tool called Weebly that generates PHP shells and allow us to gain access and do a number of cool things on the target computer. So first of all, I have my DVWA here, And usually when you're trying to pen test a website, what I recommend is before trying to use any tools or anything, after you do your information gathering, is you just go in and try to browse the website, see what you can see, just get a feel of the website, see what's installed on it and all that, and try to exploit any features you see. So for example, let's say you went on everything and then you reached the upload. We can see that this website allows us to upload a file. Now this sometimes in your penetration testing tasks, it could be a website that's allowing you to upload a profile picture, if it's a classified website, maybe it's allowing you to upload pictures of cars or whatever you're trying to add in the website. So as you can see here, the website expects you to choose an image and upload an image. So let's see if we can upload an image first. So I'm going to go on my downloads and I have a picture here in the resources, just a picture of a car. I'm going to upload it and see if it gets uploaded. And we can see that the upload was successful and it's stored in this particular location. So it's ... which means 2 directories back and then this file name. So let's see if the picture has actually been uploaded. So I'm taking away 2 directories. I'm taking away the vulnerabilities and upload. I'm only using that. And then we're going to get this location on the server just to see if the picture was uploaded properly. And as we can see, the picture has been uploaded, so that's all good. Now the next thing we want to do, let's try and upload a PHP file. And to do that, we're going to use a tool called Weavly, as I said, to create a payload or a shell, if you want to call it. And it's obviously going to be a PHP shell. You can use Metasploit, as I said, to create a PHP payload. But we're going to be just having a look on a different tool that's designed for web application penetration testing. So the tool is very easy. We're going to put the tool name, which is Weavly, and then we're going to put generate, because we want to generate a payload or a shell file. Then we will put a password for that file so that only us can access it and control the website when we upload it to the website. So my password is going to be 123456. And then I'm going to say where I want to store it, and I want to store it in root, and I'm going to call it shell.php. So very simple. Weavly is the name of the program. Generate is to generate a shell. The password that the shell is going to authenticate us with, and it's going to be stored in root shell.php. I'm going to hit enter and it's created. Now if I'm already in my root, so if I just do ls, I should see it, and we can see it right here. So the next thing is we're just going to go back to our website and try to upload that shell. And I'm going to look for a shell, and here it is. Gonna hit on upload. And as you can see now, it's telling me the file has been uploaded successfully and it's in the same place that the picture was. So all we need to do now is we're going to use the same link, and we're going to use Weavly again to interact with that shell that we uploaded. Now let's first of all see if the shell exists and it's been uploaded properly. So I'm just going to browse it through my browser, shell.php. And you can see that you get a blank page, so we're not getting 404, file not found, which means that the file has been uploaded and it's there. So we're going to try to interact with it from Weavly. To connect to it, we're going to type in Weavly, and then we're going to put the URL where the shell is. So this is where our shell has been uploaded. And then we're going to put the password. So my password was 123456. Very simple. Weavly, the URL where the file is, and 123456. This is very simple, similar to when you use your multi-handler waiting for connections or connecting to your backdoor. So we're literally just going to connect to the backdoor that we uploaded. And as you can see, now we're in the file system. So from Weavly, from this place, you can actually just type in any Linux command and it'll be executed on the target computer, and you'll see the result here. So if I do a pwd, you'll see that I'm in var www hackable uploads, and if I do an ID, I'll see my user at the moment, which is www data. And if you do a uname A just to confirm that this is the Metasploitable machine. You'll see that this is the Linux Metasploitable machine. Now we can do anything we want. We can list the files, we can navigate. You can do any Linux command that you want to do. Now we have changed, our place has been changed. Weebly also offers much more features than just this. So it actually allows you to do a number of cool things. If you type in help, you'll see all the cool stuff that you can do with Weebly. So you can try to escalate your privileges, execute SQL queries, and a lot of cool stuff that is just designed for web application penetration testing. For now, I'm going to leave it at this. And this just shows you how to use file upload vulnerabilities. The proxy that we're going to be using is Burp proxy. Now, Burp is a really big program that can be used for a lot of things, but we're going to be focusing on how to use the proxy in this lecture. So we're going to be using the proxy in a lot of lectures. I'm going to explain how to run it and configure the browser to use it once. And in the future, I'll be skipping through this step. I'm just going to say, I'm going to run Burp proxy, and you should carry out these steps. So how Burp is going to work is we have our client here, and we have the web server, just like we've seen it before. And we have the HTML website loaded on our Kali machine. So when we send a request, instead of sending it directly to the web browser, we're actually going to configure our browser to send the request to Burp. So this is our proxy running here. Burp will see all the parameters that are being posted to the website. So we're going to see the post requests, the get requests, and we'll see them after all the client code has been applied. So some websites apply client-side code, as I said, to the request before they send it. So we're going to be able to see the requests after the client-side code has been applied. This is very important because a lot of websites use filtering as client-side, and then we'll be able to bypass all of these filters by intercepting the request. Then once we modify the request in Burp, we're going to forward it to the website will execute it and give it back to us. So again, we're going to redirect the requests to Burp, modify them here, send them to the website executes it, give it back to us. Now we're going to be using this a lot in the future, and the idea will become much more clear in the future. So if you don't really get it now, just keep going through the lectures, and I think it will become much more clear. Let me show you how to configure Burp. So first of all, I'm just going to start Burp. So you can run it here from the dock, or you can run Burp suite from the terminal. Now, this is just telling me about some temp project I had. We're just going to click next to use a temporary project, and we're going to use the defaults. So we have Burp running here, and as I said, it's a really big suite with a lot of options. What we're interested in, the proxy. So we can see that the proxy is set to on, and the most important thing now is to go on options. And you'll see that the proxy is running on port 8080. Okay, now anything we do here is still not sent to Burp because we are not redirecting anything to it yet. So we need to set up this. We need to tell our web browser to send all the requests to the port that Burp is running on. So Burp is running on 8080. So now I'm going to go to my preferences. I'm going to go on advanced. Network, settings, and we're going to use manual proxy configuration. And we're going to use port 8080, and the IP is 121, exactly like it's in here in the options. I'm going to click on OK. And now anything I do on this web browser will be redirected to Burp before it goes to the website. So anything I do here will be redirected to the proxy. I can modify all the requests and send it to the web server. So let's see how is this going to work. So I'm going to go back here to the intercept, and I'm just going to click on any link in here. So if I just go, for example, on the file inclusion, you'll see that Burp here has intercepted a packet. And if we go here on the parameters, you'll see the stuff that Burp is sending. So we can see that it's asking for a page called include.php, it's telling that the security should be low, and it's sending a PHP SSID. So again, on the headers, you'll see all the headers that's been sent, and you can modify any of these values by double clicking it. So you can modify this, double click it, modify it, hit enter, and then once you're done modifying it, you can click on forward, and that will forward the packet, and then the page is displayed here. Now we're going to be modifying these things in the future, so right now I'm just showing you that Burp is set up correctly, and in the future we'll be modifying that. Let me just show you an example of a file upload. Now again, if I click on file upload, nothing happens. I have to forward the packet here, so you can see the values that's being sent. You can see the headers here as well, and I have to forward it, then the website will load in here, and I have to forward again, and as you can see now it loaded. So let's try to upload an image, and when I click on upload, again you'll see that the website pauses, and we can see all the stuff that's being sent in here. So you can see that the image name, you can see the image type, and you can see all the variables that's being set as well. Again, this is a post request, and usually you don't see anything in here in the URL, but we can modify the values in here and then send them. Again, this might not make much sense now, but in the future, once you start learning other attacks and will be using Burp, you'll see how useful this can be. Once done using Burp, because now if we close Burp, the browser will still try to redirect the packets to port 8080 where Burp is running. So if I try to open anything, I will lose my connection because it's saying the proxy server is refusing connections because I stopped Burp. So once you're done with Burp, go back to your preferences and make sure that you set up your proxy settings to not use a proxy. So advanced network settings, and then go to no proxy, hit OK, and then you should be good to go. Now if I do a try again, the website works as well. So again, this is going to be really handy to intercept post, get, and bypass filters, and also bypass any type of client-side code that gets applied to the requests made by the website. In the future, I'll be doing this very fast, and once I say I'm going to use Burp, you should take it that you need to start Burp and configure your browser to redirect packets to go through Burp. Now let's talk about how you can secure your website from file upload vulnerabilities. The main thing to keep in mind is that never allow people to upload executables. There shouldn't be a need for you to allow people to upload executables really. So stuff like PHP, bash scripts, executables like exe, com, all these files, you should never allow people to upload them because there is a high possibility that these files could harm your server. The second thing is you need to check that the file type is what you want, is what you're expecting, and check the extension at the same time. So when we were checking with our tests in the previous videos, at the low security level, obviously there was no checks. At the medium security level, there was checking for only the file type. And at the high security level, they were checking for the extension only. So what you want to do really is never allow executables. Make sure the uploaded file is what you're expecting. So if you're uploading an image, make sure that the file type is an image and the extension is an image extension. So it's a JPEG or a PNG or any other image type only. And once you do these two checks, so that and that, make sure that you recreate the uploaded file. So you check that the file is an image and you check that the extension is an image extension. Then analyze the file using some sort of a library. So depending on the programming language you're using on your server, make sure that you pass this file to a library and analyze its content and recreate the file to suit your website. Now, this is actually a good step anyway, because since you're displaying this on your website, you want to make sure that the images aren't too big and that they are optimized for web applications. So it's a good thing for your website to run faster, and it's also a good thing to make sure that this image is actually an image and it's not a harmful file. So let's just have a look on the source code. Now, I know I always say we're doing black box testing, but we're talking about the security now, so you actually have to see the source code to see how you can secure it. So I'm just going to set the security level to medium because the load just doesn't really check anything. So we're just going to go with the medium for now. And we're going to go on the upload. And I'm going to view the source. So as you can see now in the medium, it's only checking if the uploaded file type is an image. Now, I don't want to get into too much details about coding because this isn't a coding course. We're only talking about how you secure yourself and about penetration testing. So I have to cover the security part. So we're going to talk about the concepts, but not the actual code that you need to use, because you could be using a different programming language. So in here, they're using PHP. And what they're doing is they have just a simple if statement, and they're checking if the uploaded file type is an image. So we've seen how we can bypass this easily by uploading an image and then changing the extension by renaming our shell to .jpg, which will be accepted as an image, and then we'll just rename it as it's being uploaded to a PHP file. Now, if we set this to high security level, and we go back to the upload and have a look at the source code, you can see that what they're doing here, they're checking that the extension is a JPG or a JPEG, and then you can upload the picture. So they're not checking for the file type this time. So as I said, you need to check for both. Now, in the new versions of DVWA, it actually has an extra security setting called Impossible. And what that is, it basically just shows you the right implementation of each one of these pages. So it actually can't be hacked. It's the right way to do it. The DVWA version that comes in with Metasploitable doesn't have that security setting, but we don't really need to use it anyway. We just need to see the code. So I have it here on GitHub. And the right way to implement this is, if we look at this, is the same if statement. And basically what they're checking is they check the extension is an image extension. So it's a JPEG or JPEG or PNG. So that's all good. So it has to be one of these things. And it has to be of an image type. So it has to be of type image JPEG or image PNG. And it doesn't stop at that, it actually checks the sizes, but that's okay. What it also does, which I was speaking about, which is recreating the image itself. So what they're doing is they're stripping the metadata of the image, and they're using a library. Actually, they're not using that library, but you should be using that library, which is called PHP Imagic or whatever. There's similar libraries for Python and Ruby and all of that. To basically, what they do is they recreate another image from the uploaded image. Once they do that, they actually delete and destroy the old image and use the new image with a new name. So they create a new image from the old image, they rename it, and then they use that image. So they do three things. You need to check for the extension, check for the file type, recreate the image itself. That way, even if a person tries to upload a bad file or a malicious file, then you'll be able to protect your web application and your server from that file. So even if they manage to upload the file, then the file will be destroyed because of the recreation process. Now, before we dig any deeper into how to exploit and discover vulnerabilities, I'd like to pause and just go back for a second and see what exactly happens when a user clicks on a certain link. So let's say you're browsing a website and you click on any link on that website. What happens? So we have the client side. So this is the computer with the HTML website that is displayed to the user. So this is all loaded on your computer on the client. And then we have the server, which contains the code that gets executed if the website is functional and if it uses code. So when you click on a link, the HTML website or the client side part of the page of the website will generate a request. So it won't actually do any computations most of the time. Now, sometimes there is client-side code, and we'll see that, but usually the client-side code will generate a request which is sent to the website, to the web server. At the web server, you'll have some functional code such as PHP or Python, Ruby, any programming language. And that's most of the time that code interacts with the database, gets some sort of information, and then send the information as a response to the website, to the browser, and the browser will display it as HTML. So the code, the functional code or the computation code is usually stored at the server side. And the way that most of these websites work is they generate a request, they send it to the server execute the request and send it back. So when we're trying to hack into websites and exploit them, we usually play with the request sent and try to modify that request so that it performs some actions that would help us to gain information or run some certain type of code that will give us reverse connection. Now there's two types of requests. There is GET requests and POST requests. Let's have an example. So if we go here on the file inclusion, you'll see that we have a variable called page, and the value of that is include.php. So right here, this is a GET request because we can see the values of it in the URL. So we can see that page equals include.php. So this page is requesting another page to include another page called index.php. Now we won't go into detail of what that means. All we're concerned about is to have an example, and this is the example. So this is the variable that we're given a value for, which is page, and we're giving it a value of include.php. So that's a GET request. An example of a POST request is the file upload. So if we go to the file upload, when you upload something in here, so let me just upload something. You'll see that the URL doesn't get modified, but the request is sent. So the image is actually uploaded on the server and all that, but the URL still looks the same. But the website did send information. So the HTML website did send information to the server. You just didn't see the information in here because it was sent as POST instead of GET. So the first problem now is we can't see the POST requests. We can't modify them because they're not shown here in the URL. In the case of GET, we can modify them straight away from the URL. Another problem is a lot of these websites in the future, they're going to be using security and they're going to be using client-side code. So if that's used, then the request is actually modified before it gets sent. So there will be filters and stuff working on the client side that will modify our code before we send it. So the best way of intercepting requests and so that we can see the POST requests, we're going to use a proxy.